Thank you so much. All right, this is on. Yes, I wish my mother could hear that. Wasn't that great? All right. Super happy to be here today. Johan Müllern Aspegren. And I've been listening to these amazing talks here today, and I'm slightly intimidated, actually. We'll keep it a slightly less technical level. I am doing the more overview, keeping it lighthearted. Perhaps that's a good thing. It's 3 o'clock at least. But anyway, I'm here to talk about world models, worms, and bombs. Well, let's start here. For many years, the interface to the computer inner world has been a rather unforgiving one. This should be playing a nice looking... All right, you can't trust tech, can you? All right. So the interface to the computing world has been quite a stubborn one. As long as the things stick together, as the cogs fit into the holes, everything works very, very nicely, of course, and very efficient. But when it doesn't, well, I guess we've all been here. We've tried these applications. All right. Is better?
Yep.
Oh, perfect. So now everybody can hear me. That's great. All right. Enter the data exactly into the boxes using the correct formats or suffer the consequences. And we've all been there, trying to add data to a form with increasing frustration. The form does not really fit into our specifics. But it's worth reiterating. LLMs are one of the humankind's greatest achievements, if you ask me. They're up right there with the alphabet and with the printing press, and not necessarily because they can write poetry, but because they can read poetry. And not only read poetry, they can watch our TV shows, and they can listen to our radio streams and everything, and they can even understand these rambling, badly written, badly spelled, stupid things. I'm trying to ask, what is the difference between a banana and a cat? Right. Deep breaths. That's nice, isn't it? So if you will, the LLMs, paradoxically, have ushered in the end of the computer era. It is no more Windows 95. The protocol is more human 2025, which I really like. Let's hope. Oh, now it works. The video works as well. That's really nice. So, however, we learned this. I remember, was it 2023, April, when this lang chain thing came. And we learned to add documents to our prompts, PDFs, Excels. We learned how to chat with our documents, right? We created chatbots and agents that could access our very vast organizational knowledge. And that was a good thing, because 80% of our organizational knowledge is unstructured. And we thought that this is really the time of the AI. Bloody brilliant, if you ask me. But of course, this turned out to be pretty disappointing in production. And the head of our AI Futures Lab, Mark Roberts, a really smart guy, he said back in those days that the large language models are not knowledge models. That was true then. That is true now. And there are many numbers, I think, flying around today, showing anything from AI being a raging success. I work with some clients and actually have it in production, but we also see a lot of people coming back very disappointed. Our chatbots, we can't rely on them. They are not 99% correct. They're not 95. They're like 80% correct. And of course, if you can't trust it, you can't scale it. And then I came in, and then a lot of people say, all right, but Johan, let's keep human in the loop here. I say, if you say human in the loop, you're basically giving your AI an F. We didn't invent AI to have human in the loop. We invented AI in order to be able to automate processes, right? What if we add guardrails and all these things? Well, it's still the LLM pending, right? It's LLM performing the reasoning and adhering to the guardrails. So, nope, it doesn't really work like that. And I like to think of this as a tennis game seen from above. It's hard to see this, actually. Right? You can see the players moving, right? But you can't see the ball here. And if we create a complex algorithm, we could probably come up with, if we put a lot of effort and GPU and hours into it, perhaps we could create some sort of smart algorithm that could help us predicate or forecast how these players would move, at least initially in the beginning of a game. But it wouldn't be more than 80% correct, because it would lack the world model, right? It would lack information about the gravity of a ball. What's the time? Oh, great. They would lack the information about the gravity of the ball, the feel of the ball, whether it's a clay or grass, the ATP ranking of the players, the rules of tennis and all these things. All the things that goes in what we like to call a world model. I don't really like the world model, to be fair. Because as soon as you say we need to put world models into our AI, you need also to define what you mean. And we don't, and then we say, oh, we're not meaning that we need to put the whole world, as an understanding model into the AI, but but enough to let it make good decisions. So we're actually talking about some sort of decision model. But it doesn't really matter, because all AIs, and to be fair, all organics, and this is where the worm comes in, even the smallest worm needs a world model. It needs a world model because it needs to take in the messy input from its sensors, and it needs to understand and model the world because it wants to forecast. It wants to be able to predict what happens if I do this. And if we only have an LLM trying to mimic a tennis game without having a world model, without having any understanding of gravity, the rules of the game, clay or grass or whatever, and this is what we end up with, right? 80%, no, not even 80% correct. All right. So what I'm trying to do here, then, so I thought we need to be able to talk about this. We need to be able to show this in a good way. And of course, this is something we talk with a lot with clients. And whether it's in pharma, talking about supply chains that we need to model in order to be able to create resilient AI assistance, or if it's in life science, or if it's fraud detection, whatever. It is about giving these modeling a relevant enough model, world model, or decision model for the AI to act it in. And then we should also remember that all models are wrong, but some are useful. So how to show this? And I thought it's too boring to show this old supply chain assistant. Oh no, there's a fire in the site. Somewhere in South Asia, it's always a fire in the production site in South Asia, or there's a ship in the Suez Channel. And then the AI needs to sort of remodel everything and find a new way to get the goods to Europe. Well, I was thinking, so that is important decisions, obviously, but what if we took it yet another notch? What if we used AI? What if we created a chatbot or an AI assistant that could help us disarm a bomb? Wouldn't that be nice? AI assistant bomb disarmament support unit. And as for our bots that are going to help us out today, of course, we have first the generic LLM. So this is a bit of a, it's not a nice move to put an LLM, generic LLM, to do this, because obviously it has no context of the bombs or the information, because we are using mocked bombs, obviously. But we keep it there for kicks. Then we have the RAG, which is interesting, because when I show this, there is a lot of companies that are using RAG, and they're very happy about it, and they feel this is really, really great for our internal documentations or customer chatbots or whatever. Yes, we might see that it might have a problem. And then our third bot that's going to help us is one that actually has a modeled, it's not really a world model, but it has an accessible knowledge graph that it can use in order to understand what's going on and how to identify the bomb and how to come up with a good procedure to solve it. So This took a little bit of a while to generate, actually, because you need to come around, you need to talk a lot to the poor chatty. That this is a mock situation. We're not creating real user guides for bombs here. So in one way, the guardrails are working. Well, we do have 3 bombs here to work with. One is the training bomb. You can see it's easy to see because that has a small green icon LED on it. There is the urban deployment variant. It has a warning triangle. That's nice. So you can see it's that. And the third one is the sort of the sturdy, heavy metal variant that you use for certain situations. Now the problem is that someone fooled up a little bit early on here. So the training model, you can't, I don't know if you can see that, but the disarm procedure includes cutting the red wire. And as we know, that's seldom a good idea when it comes to real bombs. So let's see how this plays out. Oh yeah, the framework. So the small application that we have, we can select our bot. We do have a, we have the generic LLM, there's the RAG, and there's the graph. We have our bomb roulette, so that we can spin it, and then over here, we will try to talk to our support chat, and we have 60 seconds, of course, or things will go bad. All right, first out, chatbot 1. And we set it off. We click it, we spin it, then of course there's a little bit, and to make things a little bit more interesting, we took a local model here. I know that we were talking about local models earlier, and they're great, I love them, I love local models, but they also give a little bit more interesting failures here. I don't think that the GPT would make much better, but what's coming out here is pretty interesting. All right. So you start asking us about what's going on. Understood, the trigger is purely electrical, activated by the blue. You can see it's hallucinating its mind out. I tell it nothing happens when I do what you say. Oh, the time is approaching 0, so now it knows that we are getting close. Touch the blue wire for exactly, and nothing happens. And this is fun. Why don't you use an EMP, like an electromagnetic pulse? And but I thought, no, I'm not going to let you off that easy. That will wipe my phone, I say. And then it says, oh, yeah, I see how that's a problem. Stand by. And of course, and now we have a post-mortem. All right. So we all know this. It just came up with a lot of things, and it argued about what we have or not what we have, and all these things, and obviously no context. And it's interesting that we still need to talk about these things, because every week we have a meeting, global meeting with the AI lab. We go through the most interesting articles and news of the week, and we still see people being surprised. Oh no, GPT-5 hallucinated when we tried to send MRI scans into its, and ask it what's wrong with my brain. And this was a Stanford research paper done last week. It's amazing, isn't it? So everybody knows we shouldn't be using that. How about our RAG bot? And I think that this is really cool. So now we're just going to do all these nice things. We're going to give it, ingest all the information. And it's not much information, so it should be pretty easy for it. And just go through the sort of, I love the whole RAG thing that we chunk the information, we vectorize it, and then we start matching its semantic similarity. I don't understand the math behind here, but I think it's super great. But basically, it gives us, really gives us a good search. Helps us to distinguish between the Queens, the rock band, and Queens, the reality. So we're going to use that. And so you see, now we have our RAG bot running here. And we got the city urban deployment variant. So I found this bomb. It has a yellow triangle, it says. That's what I'm saying. And of course, this is fast. This is super fast. That's one of the great things with the RAG. And based on the description of the yellow triangle marking, it's totally correct. It finds the correct bomb, or it identifies the correct bomb, but it asks us in some way, for some reason, to cut the red wire. And what happened here, and I was not expecting this error. I was expecting the error to be some sort of density confusion thing that typically happens to RAG when the information is too close. But what happened in this case, and it's very, very clear here from our little JSON from the log, that we have a chunk bleed. So the document that it chunked, it was a very sloppy chunk strategy, I can tell you that. Basically just take, 500 characters or 200 characters, chunk that. Of course, if you send this information, this is the best hit, but if you send it to the LLM and ask it, now, tell us why, tell us how to disarm it, then it says cut the red wire because that was connected to the previous. So when I meet people that are using RAG, I ask them what chunk strategy do you have? And there are really, really good chunking strategies, of course, and there are so also these semantically driven chunking strategies coming up. But if someone uses something like this, then you're in for a world of pain. All right. So now the graph. Now the bot that has a world model. The interesting thing is that it has a structured information. So it's very, very easy, right? And in this case, I was lazy, so I just took the document and I threw it onto an LLM and asked it, just take out entities and identify relations between between the data. And it modeled a really, really sweet little graph where we have our devices, they have the features, everything. Super nice. And it also has the procedures and everything connected. And this enables us, of course, to have an AI that actually reasons. All right? I tell it this red wire, blue wire, yellow triangle. I really need to know, does it vibrate when you move? And I said, yeah, it does. And it says, super cool. In that case, this is the urban deployment thing, cut the blue wire, everything is good. And we don't need to run from screaming from the building. And what happened here is of course that, and you see that already, that now we have something that we can basically trust. And now instead of generating the answer, we added a little bit of an extra bot here, actually, the text-to-cipher bot, which is a local model that I love a lot. And it generates the cipher, or Sparkle or whatever, returns back video information, and this is used as to fact for your answer. So, and the beauty of it, of course, is that the LLM is not generating the answer, but the question. And there's a huge difference. And I'd say that trust is built on working relationships. Now, for how this works out in real life, we've done this, or actually I've been part of at least basically everything I do in AI right now seems to be based on graph in one way or another. So we're creating a really, really big and sweet and interesting project together with researchers at Lund University, where we are trying to identify signs of a rare lung disease, only based on the information about the medicine that people have been given over the years. And in order to do that, we needed to, it was not enough just to have the normal ontologies, the ACT and the ICD and the UMLS, because the world is so messy. There are so many interesting diseases and medications and symptoms and everything that we actually needed to fetch 5 official ontologies from Maryland University, from Stanford, that were describing diseases and sicknesses and medications, whatever, and then implement them in one graph connected with the medication that people would get, and then start to find the measures. As for detecting fraud, super interesting, because here you want to do, typically, the challenge is that the data is multimodal. So there is cameras, there is Facebook, there is Reddit, there is text, there is speech, there is all kinds of interesting information that you want to extract and put into a graph and connect it. And then this one, the one we did with the big pharma just the other day, where we're taking 4 million points from typically Databricks, modeling that into a supply chain, trying to understand how you would take the raw material over sites and over logistics partners and everything, and packaging and mixing and everything, and out to the customer distribution centers. And that was actually a beast of itself. So let's see. And so I'd like to share with you now 5 steps that I typically go through when I try to approach one of these modeling challenges. So the first thing you want to do is that you want to immerse yourself deeply into the data without any assumptions. And in this case, it's a good thing to come from innovation because you're used to the chaotic sort of first stage of design thinking, where you don't know anything, you try to just forget everything you know. You need to start there. You need to have a lot of meetings with the people that own the data, with the business and everything, but it won't be enough. All right, so immerse yourself, and once things start to find a foothold. That is step number 2. Find a foothold, something that doesn't move. For us, it was being able to map, to see how the raw material went to one brand or ready product here. We could follow the whole line using the graph. Then we know, okay, this is where we're starting, and then you build on that. And then comes step 3, which is enrich, which is also the show me something I hate. And this is because if you ask someone, how does your process look like? Or how does that material, how is that described? They won't tell you the whole story, but when you when you show them your impression of it or your first application, this is your material, they will say, no, that's wrong, that doesn't happen, and that material is not there, and that is that, and this is this. No. So you need to do that. So that's why it's a very, very iterative process. Once you've done that, you abstract. Because now you have a lot of interesting data in your graph. Now you want to build on it. So for example, we were creating, now we had information to create processes, connect them correctly. Now we can put in logistics services, quality event services. You can expand on your data, and then eventually you need to align it. That's the final step. You want to align your your ontology, your local ontology, with an enterprise ontology. Otherwise, it doesn't really make sense. Because if your ontology is talking about product, and the guys that are over at shipping, they call it the same thing, brand, they have a huge problem. So you also need to align your ontologies all over the place. And then one final thing that really came with us, and is you need to keep the data lineage. Because what happens if you create something like that, if you create a really large graph of millions of nodes, we did that, and then we got the question, oh, this is great. So can you tell us which materials go through this particular site or that port in Utrecht? And say, yes, no problems. And we can ask much more complicated questions than that, but sure, we'll do that. They look at the list, and the first thing is they don't trust it. Right? So in that case, you need to be able, at least initially, to prove. You can show, yeah, this is the line here, this is the material, this is the property name it has in Snowflake. And then they start to trust. So actually, data lineage. So actually, building trust into the system and creating trust with the chatbot is not only with the chatbot, but also with you, the designer, the architect of the chatbot. Thank you so much.
Thank you so much, Johan. We're so lucky to have you here, and thank you for an incredibly cool and interesting presentation. I think we have time for one question, if that's fine for you. So already now, do you see a clear different categories of use cases for when to use vector approach and when to use this graph database approach?
Oh yes, I think if you know exactly what kind of questions you will be asking in 2 years, there's no need for graph.
Great.
That's it.
Yeah, no, but perfect. Thank you. And as a thanks, we want to give you this umbrella.
Thank you.
And thank you once again for being here and giving a warm applause.
All right. Thank you so much.
Thank you, Johan. Thank you.